When we describe pressure, we know that the particles in a gas are constantly moving and that there is lots of empty space in between those particles. And so as those molecules in the gas phase are moving around, some of the things that they're doing is they're colliding with each other, but they're also colliding with the walls of the container that they happen to be in. And so the two factors that go into determining just how much pressure a gas is going to exert is, first of all, the force behind each collision, and that's directly related to the kinetic energy and the temperature of the gas overall. And the second factor is just how many collisions are taking place against the wall of the container. And so this is determined by the number of moles, or the amount of gas that is present in the container. When you have low tire pressure in your car, you take it to the gas station, you hook it up to the air pump, and you pump more air into your tire. You're forcing more molecules of oxygen and nitrogen into that tire, so there's going to be more collisions with the inner wall of the tire, hence more pressure. Now, on average, at sea level, atmospheric pressure is usually measured as 101.325 kilopascals of pressure. And there are other equivalents which we'll take a look at here in just a moment, but that is referred to as standard pressure. The higher up you go in elevation, the less air that you have literally above you, and so there's going to be gradually lower and lower levels of pressure the higher up you go in the atmosphere. The pressure that a gas exerts can either be directly or inversely related, or even proportional, to other characteristics of gases that we use to define how much of a gas we have, and those would be characteristics of temperature and the volume that it occupies. Now, we define standard atmospheric pressure as 101.325 kilopascals, but again, there are other units of measure that can be used to describe pressure, just as we have multiple units of measure for length, or for temperature, or for volume. What you see here on the screen are the equivalent values. All of these represent standard atmospheric pressure, just in different units. The earliest measurements of pressure involved columns of mercury in a glass tube, so the millimeters of mercury and the inches of mercury both come directly from those early measurements of atmospheric pressure and gas pressure. The torr is actually equivalent to a millimeter of mercury, and that's named after Torricelli, one of the early scientists that did work with pressure measurements and the columns of mercury in a glass tube. PSI is pounds per square inch. That's fairly common to us. A lot of times you look on the sidewall of tires, it tells you how many PSI the tire should be inflated to. Basketballs, other sporting equipment, tells you how many PSI of pressure should be in your piece of equipment. And then with all of those different pressure scales, scientists looked at them and thought, we've got all these different pressure unit scales and all these different numerical values. Why not just simplify things and make a pressure unit scale where standard pressure is 1, and hence the atmosphere, or ATM scale, was born. So all 6 of these values that you see here, all 6 of these units, are all equivalent. The measurements that you see here are equivalent to standard atmospheric pressure, and because they are equivalent to one another, they can be used as conversion factors. So when we convert pressure units, like any problem, you first start by writing down what you're given. Second, you need to set up your conversion factor. And to convert from one pressure unit to another, we're going to use that set of 6 equivalent values for standard pressure. How we're going to set the ratio up is that you put standard pressure in the units that you're trying to get to on top of the ratio. On the bottom of the ratio, you put standard atmospheric pressure in the original units that you started with. In setting it up this way, you can cancel out the units, the original units that you began with, leaving you with the desired units, and then you do the math and come up with your final answer. So if we take 2 examples here, 477 kilopascals of pressure, we want to know what that's going to be equivalent to in torr. So we start by writing down our original value, 477 kilopascals. Our ratio, we want standard pressure in the desired units, so that would be 760 torr, that will be on top, over the standard atmospheric pressure in the original units, so that would be 101.325 kilopascals. Kilopascals will cancel out, leaving us with units of torr, which is what we desire. So now in doing the math, simplifying, we get 362,520 in the numerator. Notice we're going to save our rounding with our sig figs for the very end because it's all multiplication and division. It also bears mentioning that when we determine the sig figs in our answer, it's only the original measurement we're going to consider here because the 760 torr and the 101.325 kilopascals are both reference values. Solving and rounding off with proper number of sig figs, you should come up with 3,580 torr. You pause the presentation at this time and give the second example a try on your own. When we set this problem up, we're starting with 26.5 pounds per square inch, and we're converting to inches of mercury. So your conversion factor would have 29.92 inches of mercury on top and 14.7 psi on the bottom in the denominator. Pounds per square inch cancel. Simplifying, it's 792.88 in the numerator, 14.7 in the denominator. Again, we're limited to 3 sig figs by the original measurement, and when we solve and round off with proper number of sig figs, you should come up with an answer of 53.9 inches of mercury.